Welcome to Krakow, welcome to Poland, obviously, and welcome to this session on Kotlin. Now, I'm assuming the majority of you here have probably heard of Kotlin, maybe not played with it. I've seen it a little bit. If I got that right, great. If I got it wrong, just keep it to yourself. And I'll show you a bunch of different things with Kotlin. And I will do it a little bit differently this time. I'll compare it a little bit to some other programming language, namely we'll pick Java today, to kind of give you a feel of where and what we try and provide you with value, okay? And just to get started, this is my main function. So you can see it up there, and I can write hello, and then I can run this, and that's as simple as it gets. So to start with, you don't have a public static void main, and you don't have a static class. You just have basically top-level functions. As I always say, it's kind of like JavaScript, but in a good way. And you can basically define your functions as you like, right? So I can say function, for instance, print message, and then have a parameter here of type string, and then print line, and then the message, okay? And I can do string interpolation here and do whatever I want. Now, notice that there's no return type. By default, it's unit, and you can omit it if you don't have a return type. And functions, again, conciseness of Kotlin, so what we try and do is make functions as simple as possible and as easy as possible to write and as concise as possible to write. And if a function returns an expression, returns a value, you can just write that as what we call a single expression function. So essentially, if I do a sum, for instance, x int, y int, I can just write that as x plus y, right? I don't need to explicitly put the return type. I don't need to open the curly braces, close the curly braces. Just write it as simple as that, okay? Then, of course, you can call these functions anywhere you want. Print message, something, okay? Now, how does this help in terms of like what you already have? You're like, okay, the syntax is a little bit more concise, and I write fun instead of not fun, and I write unit instead of void, but what does that give me? So let's take a look at, for example, overloaded functions in Java, right? This is overloaded methods in Java, and I'm going to split that vertically. And now take a look at overloaded in Kotlin, right? So you can see that this is already somewhere where it's cutting down code. I don't need to do these overloaded methods anymore in Java. Right? Obviously, I'm putting this outside in its own like top-level function, but this could actually be a member function of a class. So don't worry about saying where's the class. The class is somewhere here. The class is here. There you go. Now you got the class. There. Now you got the class. Happy? There. People think, oh, there's no classes in Kotlin. Yes, there are. Anyway, so already cutting down boilerplate code. What am I doing? Essentially here, I'm just passing in optional parameters, right? Simple as that. Why do I have to have all of this with all of this code over and over again if essentially I'm doing the same thing but with different number of parameters? And then, of course, I can call this, and I can say, for example, val is here. We'll now create a class. By the way, val is something in Kotlin which means immutable, read-only. It means that I can't reassign that. If you want to reassign something, you declare it as var. My rule of thumb is don't do it. Just declare it as val and work towards having read-only variables. And then I can do is here and print message, right? So I can pass in one parameter. I can pass in two parameters. I can pass in three parameters. And the good thing is that you can see that this is actually, this is IntelliJ giving me the name of the parameter, but we actually have named parameters in Kotlin too. So if I want to pass in the suffix first, I could just put suffix and then pass in the suffix, and then here I would say the prefix and pass in the prefix, and then this would become the actual message, right? I can alternate the order in which I want to pass in the parameters. And this is useful, of course, not only for alternating order, which why would you want to do it? But anyway, but it's useful when you have multiple functions, probably legacy, that has 200 parameters, and you're playing a game of true and false, right? So you can start to name those things. Or you could refactor, but why bother when you can hack things together, right? Now, Kotlin does have classes. As I've shown you, I've created a class, and one of the typical quintessential examples that we show is a class in Java. So let's say customer job, customer type Hadi type. Customer Java, split vertically, and let's show customer Kotlin. Okay, there you go. Now, and again, you're going to say, oh, big deal, you know, any IDE generates this for me. Yes, it does, but the IDE doesn't maintain it for you. And the IDE doesn't come and say to you, oh, don't look at that, Hadi, because that's just boilerplate code that I've generated for you, right? I don't know if someone's gone and modified all of that code. So all of this, essentially, is declared with a single line of code. And the data class over here, when I add the data modifier to it, what essentially that is doing is providing me with some new functionality. Namely, it's giving me the equals, the hash code, the toString, and the copy, which we'll see in a moment. What you'll also notice here is that essentially I'm doing the whole property declaration and constructor also in a single line. So here I'm declaring 3 properties. One of them is read-only, the other 2 are read-write. And that, in turn, is also creating a constructor. That's the short syntax. You can also do this in a longer syntax. One thing to notice, if you're not familiar with Kotlin, is that we don't have fields as such. We just have properties. And then you access these properties with accessors. There's no getter or setter. Well, there is, but it's under the covers for you. When you talk Java to Kotlin, you get the Java to Kotlin. There you go. Or Kotlin to Java, you get the idiomatic approach in each language. But if you're working with Kotlin, you can just use them directly. So I can say, for example, val customer equals customer Kotlin, and then this will be 1, A, B, and then do customer dot email equals something. Okay? So a lot of boilerplate code you're saving there. Now, one other thing that you have is also the copy class. So here, you can see that I have a data class contacts, and then I have a list of type email, which in turn is a data class. And if you do a copy contacts, this in turn is actually going to do a deep copy, so it's going to copy everything for you, right? So you're going to get all of those different properties. And you can, in fact, override this. You can say, you know, I want the company name to be, when I copy, I want, for example, the company name to be something else, and then it will, and then it will default the other ones to whatever the value is. So you can override the values as you're doing a copy clone. Okay? We use data classes. As you know, we like data classes. Initially, we used to have tuples, and we got rid of them because one of the key aspects of Kotlin is to write maintainable code. Now, we can't guarantee that because, you know, we are developers, and we can take any language and make it completely unreadable. And as Kevin Henney recently said, that, you know, there's a difference between every code is readable. It's the bigger issue is whether it's comprehensible, which is where we basically struggle. But we do have pairs and triples, right? So for instance, let's say that I have a function that returns pairs. So I can just return a pair of type string, and we also have triples. So if you go beyond triple, then we say for you to use a data class. So here I could just do pair something else, right? Now, if I call this function, how do I access those properties? Well, the first one is with first, and guess what the second one is going to be? There you go. You're really interactive, aren't you? Anyway, so the second one is going to be second. Now, that's kind of sucks because, hey, we're talking about readability, comprehensibility, and what is first, what is second. So you have destructuring of variables in Kotlin. So you can do, for example, name and email, and then do this as return pairs, right? And now I can access those in a much more nicer way, giving me context and meaning of what exactly it is that I'm accessing. So I could do now print line email. And this destructuring you get when you're working with data classes, you get when you're working with pairs, you get when you're working with lambdas. And notice here that it's saying, well, you're not actually using name. So that's a hint that the compiler is giving you and the IDE is surfacing for you. What you can do is also use the underscore and say anything that I don't use, I'll just use underscore for, and then just, you know, get rid of all of those hints. But more importantly, tell the developer that's reading this code that this value is not important. And as I said, this destructuring can work with anything. So for instance, we've got a contacts or an email class, so I can say, you know, this is the name 1, and this is the email 1, and then do exactly the same for email, right? So I can say something and something. Okay? So it's not only with pairs, it also works with data classes, and it's basically following the convention of the first parameter is the first position, the second parameter is the second position, so on and so forth. Okay? Where else do we try and improve on the boilerplate code that you write? So how many of you love design patterns? It's okay, don't be ashamed. Raise your hands. Singleton, let's see, singleton in Java, right? Now this is a singleton in Java, which is fantastic. Not advocating the use of singletons, I'm just saying this is a singleton in Java. And let's take a look at the singleton in Kotlin. We'll go here and we'll do singleton Kotlin. That's a singleton in Kotlin, because we essentially have objects. So much like in normal languages, you have a class, a type, and then you create an instance of that type. In JavaScript, you only have objects, and then you try and mimic everything you learn from another language and bring classes into JavaScript. In Kotlin, we have both. We have objects, which just represent a single value, and classes. So here I can just create an object, which is a single Kotlin, and it has a property, and of course I can access this by just saying singleton Kotlin and property, right? And then assign a value. No, you don't assign a value to global things. You don't have singletons that you can change values on. That's kind of a no-no. For read-only, though, it's kind of nice. And notice that I'm not advocating, again, saying, oh, well, since Kotlin makes singletons so easy, let me just create singletons throughout my entire code base. Nope, not saying that either. Okay, what else? So one thing that we added to Kotlin is the concept of a type alias, right? So here I have, for instance, a data class, and I have a name, customer name, and an email. Now notice the customer name is actually the same thing as a string, right? But it's providing me with more semantics. Here I have, and I've done that using this thing over here called type alias customer name to string, meaning that this property is actually of type string, but to provide more meaning, to provide more semantics, I'm using the name customer name. But I can pass in, it will verify this at runtimes it's string, at compile times it's string, you can pass string where it's customer name, etc. Okay? Now this comes in useful actually, sometimes combining this type alias with something else, which is called the deprecated annotations. And I'll show you how this works. So let's say that I have a class, customer, and we're going to now come here, and I'm going to rename this. Well, actually, I'll just comment it out, right? And what I've done here is essentially created a deprecated annotation that comes with Kotlin that you say customer is now called awesome customer, and replace with awesome customer. Now this actually doesn't work. Eventually it will be implemented so that you can do Alt-Enter and replace that in the IDE. And notice that now type alias, I'm saying customer is awesome customer, right? So what happens here is that now when I hover to this, it says awesome customer is deprecated. I did that the wrong way around. Awesome customer is deprecated, and you should use customer instead, right? Now the good thing about that is that this allows you to refactor things and rename things without potentially breaking people's codes. But then you're probably thinking, why do I care about breaking people's code, right? Let me just do that myself. So it is actually quite useful in that sense, and we use it quite a bit. You can do like a multiple phase change. I'll rename something and then issue a warning, and then on the next one, I will remove that, deprecate it, and away we go. And nobody can complain, because we don't complain as developers. So that was a joke. Here's another example. Of course, it's not funny when you say that was a joke. So I have conditional expressions, Kotlin, conditional expressions here, right? So for now, just let's focus on this one. Let me actually close this one. And I have a string parameter. So I'm declaring the string, and then I'm doing if args length equals 0, assign a parameter to it. If not, whatever. I've got another case where I'm returning a value. And then I've got a switch statement where I'm saying if it's case 1, if it's case 2. If not, then if the value is within a specific range, then do this, etc. Ignore that. It's going to say, oh, this is always going to be true or false. But for the case of this demo, it doesn't matter. So what about Kotlin? Where do we kind of try and improve here? Well, the first thing you can see is that an if and a when in Kotlin is an expression. So I don't have to, well, it can be treated as an expression or as a statement, but I don't have to explicitly declare a variable, assign that variable based on the actual branch. I could just return that as the result of the if expression. This is a single line if expression. If I have multiple lines, curly braces, then the last line of that branch is going to be the return value. So here I'm doing value can be 1, 20, or I can write multiple statements and then the last value is going to be the return value. I could even return a string here, right? But if I return a string, the compiler is going to give me a warning and say, well, conditional branch is returning a type string, so I'm casting the return type to any. Any is the top level object in Kotlin, right? Meaning that if you want to, you can return a different type per branch. Why would you want to? I don't know, but you can do it. Well, there are cases, obviously. Now, in the when statements, similar to a case, but we do allow certain level of pattern matching. So you can see that I have 1, I have 2, which we had in the Java case. Then I can have a bunch of values, 3, 4, 5. I can even check for whether it's a type. I can even check for whether it's in a range. And an else branch, I can even call a function and have the function calculate a value and return whether that's a true or false for that statement, right? Point being what? It is very similar in code to what you've seen in Java, difference being that it's saving you a lot of pain when you're writing this code, right? It's allowing you to be more concise, more expressive. And that is essentially what Kotlin is about. It's not about a single feature that you look at and say, okay, this is cool, but I can do this in Java. You can do everything in Java. And when I say Java, I mean you can do everything in assembly. How many of you here program in assembly? Oh, come on. 3 people. Awesome. Good. Not still, no? Oh, yes. Still? No? Okay. Right. Now, another thing that we try to help with is Java nulls. This is your typical example of a Java null, right? If customer is not null, if customer.getName is not null, if customer.getName starts with blah, 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 then do this, do that. How do we solve this problem in Kotlin? Well, we said we don't have nulls. We do, but we don't. Well, we do, but I'll tell you, yes. Anyway, so by default, we don't have nullable types. So when you declare a type in Kotlin, right, if I come here and I say val my string equals some value, and then I do my string equals null, that's not going to work because it says this type is not nullable, right? If I initialize it to null, then it will work. You can also do explicit type declaration in Kotlin, but you normally don't, so I can do string something. That, again, is going to give an error because string is not nullable. And one day I will write something properly. Now, what I can do to make this nullable is add a question mark and now say this is actually now nullable, right? And so I can assign a nullable type to it. Why would you want to do this? Again, try and move away from nullable types. In Kotlin, by default, you don't declare nullable types. However, one of the purposes of creating Kotlin was to be able to interop with all of the existing Java code that we have and you have. And when you're interoping with Java, you're going to face nullable types. So you need to have that question mark there sometimes to be able to interop with nullable types. So in the case of Kotlin, what we try and do is make it a little bit nicer to work with. So here, you see that basically the same kind of code. In this case, I don't have to do any checks because it's a customer Kotlin, and I'm saying that it's not nullable. Okay? In this case, however, given that this is coming from Java, I can actually explicitly say that this is going to be a nullable type by adding the question mark. Since I say it's going to be a nullable type, then Kotlin, I would have to do kind of like in line of if customer is not null, then do something with it. You can do a much shorter syntax with that by just using the question mark here. So that's basically saying if customer is not null, then if name is not null, then if starts with blah, 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 and if that equals true, then do something. Okay? So when you're working with Java, you have to decide whether the type you're actually working with is nullable or not. I could actually remove this and say, there you go. I now know that this will never be null. So you can use the not null annotations that the different libraries provide to kind of recognize whether that's going to be nullable or not. What you can't do is remove that and then get null reference exceptions at runtime and then say, well, didn't Kotlin say that it removed null? No, because you're explicitly saying that this is null. And as I always say, if you really want to be brave, what you can also do is declare this as nullable and then do customer $! And that means I don't care. I miss my null reference exceptions. I just want you to blow up at runtime. Okay? So you can do that as well. Why you add that? Don't start. This is one of the main things that people fall into the trap. Like when they start to port over their Java code, initially they're like, oh, well, this is null. What should I do? $! No, you don't. Not having nulls in the language is actually forcing you to think more about nulls, essentially, right? Because it's not the happy path, right? Normally when we do error control, it's like, well, if it's not null, I'll do this, and if it's null, then I'll pretend that nobody saw anything, right? Now it's kind of saying, what happens if it's not null? Oh, I don't know. Right. So what else? One of the things in Kotlin is extension functions. Right. So what I can essentially do is do fun string Krakow, and then what that will do is essentially print line Krakow is great. Okay? So now I can say Poland and Krakow are great. Okay? So I've just added a new function to Krakow are great, right? It's only done Krakow. Why? Because I've written Krakow are great. Now, what I could do is actually reference, this is essentially what it's doing, is adding an extension function to the type string. And I can extend any type in Kotlin or Java, right? So you're kind of thinking, well, why would I want to do this? Again, to make code expressive. Now, I normally wouldn't do, add a function in my code base that's called Krakow. We can do something like, to camel case with inverted colons, German style, right? I could do something like that, right? Because you know that in Germany they do the inverted things, right? So this gives you, again, expressivity. I don't have to take a string class, inherit from it, add a new method to be able to just add one more function. Okay? This is where the beauty of this extension functions are. And if you actually look at the standard library, which you'll see in a moment, most of the functionality you get are, in fact, extension functions over generic types, meaning that you get a whole bunch of functionality independently of the type of things you use, whether it's string, whether it's collections, etc. Okay, and we'll see that when we take a look at lambdas. Now, talking about lambdas, lambda in Java, I have lambdas in Java. If I want to declare something in Java that is a higher order function, I say, well, I can do it in two ways. I can define an interface that takes two parameters, or I can do something like a by consumer or a by function or a whatever, and then have all of these different types, and then pass in the parameters that I need, and then the IDE will say to me, okay, this is a lambda, you don't have to implement a root handler, you can just pass this in as a lambda, just like I'm using the using listener in Java, right? Here, I'm creating a new instance, but I can do Alt-Enter and replace that with lambda. Okay? You can do pretty much the same thing in Kotlin, right? Except you don't have to have the explicit type declaration. You can just pass in lambda like that, and you'll see that this is omitting the brackets, which we'll see in a moment. But how do I work with lambdas in Kotlin? And how do I declare higher order functions? Essentially, we're using always the same syntax. I don't have to know about by function or things like that. I just say int, comma int returns int, meaning that this is a function that takes two integers and returns an integer, right? And then I'm invoking that function. Here is a function that takes no parameters and returns void, right? So technically it's not a function, it's a method. But anyway, so always following the same syntax, always. And now it clearly says to me, oh, this is a lambda, I can pass in a lambda. And when you want to invoke it, you do higher order, and you actually pass in the lambda, which we use this syntax, which is the same if the last value if the last parameter to a function is another function, then I can omit the curly braces, right? And then what I can do is make this multi-line, which will make it a little bit nicer. Then you say, why? Well, then I can do something like this. I can take, create a function called using, for instance, object, which is closable, and then have a body that basically what it's doing is going to invoke the body, and then I'll do finally object close, right? And then what I could do, imagine that I have a val closable thing here, whatever, we'll close it, whatever. Imagine that that works. And then I could do using closable, and then not have to worry about that resource being freed, right? Using is a statement that we have in C#, and you have like similar try with resources, but essentially giving you that fluidity of feeling as if you are adding functionality to the language in a way that is very expressive and easy to read and understand, okay? And all of these functions, as I mentioned, we have like, when working with functions, all of these things are part of the standard library. So by the way, this is how you create a very nice, easily you create a list of numbers in Kotlin, just 1 to 100, and then on the numbers, I can do things like filter, it is less than 100. So it is following the same syntax as Groovy, saying that if the function that I'm passing in is a single parameter, I don't have to explicitly name that parameter. So instead of doing something like x, and then x is less than 100, I can actually convert that into using implicit, okay? And then I can chain these, map to it, div 100, or what have you, okay? So these functions, as I mentioned, they're basically part of the standard library. You can see that they're extension functions on iterable of t. So I have all of this functionality for all the different types of collections that I want to use. And Kotlin doesn't provide right now its own collections. It basically provides a set of interfaces on top of Java's collections, by default moving towards immutable. So when I do, for instance, val customers equals list of, and then a customer Kotlin, that is going to create an immutable customer for me in Kotlin. And I can add a second one, customer Kotlin, and then get whatever I want here, okay? One other thing, difference with Java, is that like in Java, you would have the Java streams over here, streams in Java. So you would, the equivalent of what I did is 1 to 100 is in stream range, 1 to 100. The difference is that this, in Kotlin, all of these lists are eagerly evaluated. If you want to do lazy evaluation, then what you do is you just write as sequence, and you can do that to any collection, right? And if you want to do it to something a little bit more complex than a collection, what you can do is use the top-level function, generate sequence, and then here pass in a seed, and then on this basically generate the code that you want to, and then on that map it to, or filter it, it is less than 100, and then for each, and then here print line it, etc. Chain those up together. Okay? One other thing that we've tried to, again, focusing on, it is just more compact, more concise, easier to read. Another thing that we have, which is kind of nice, is the return types, return types. Our way of implementing algebraic data types, which is kind of useful, where you essentially say that, you know, a type, a function, for instance, is returning one type or another. A type can be one type or another. The way that we represent that in Kotlin is essentially through a hierarchy of classes, but then what we do is add the seal modifier, which essentially means that this hierarchy is closed, meaning that nobody else can ever inherit from response. Right? And these are inside. I can actually take them outside and then have something like failure, success, and response, and then get rid of all of these things. And notice, I don't know if you see it there, but this has gone green, right? This has gone green because that's another thing that we have in Kotlin, which is smart casts, which essentially means save me having to type things over and over again. And instead of casting this to type success, I can essentially just assume that it is success because the compiler has done that for me. So these are some of the things that Kotlin provides you in order to be able to work more concisely and more fluently and more rapidly and more fun. Thank you.